We did the octal coding. In the octal coding, the base of the system is 8. So you had to express the given number as sum of powers of 8. And we went over that example of finding octal code. Yeah, this example. So you can do this manual process of, the long process of expressing the 459 as sum of powers of 8, then the coefficients of the powers 7, 1, 3 will be the code. So you present that as your code octal code of 459. We read it as 713 because it's not 713. 7 doesn't represent 100. 7 represents 8 to the power 2. So you shouldn't, reading it as 713 is not appropriate. So read it as 713. Same way for the hexadecimal code. So let's go to hexadecimal code. To find the hexadecimal code, you had to express the given number. Here the example is 1279 as sum of powers of 16s. So start at 16 to the 0, 16 to the 1, 16 to the 2. 16 to the 2 is 256, but 16 to the 3 is way more than 1,279. That's why I stopped at 16 to the 2. And then to figure out how many 16 to the 2s are there in the number, to figure out this number, you divide the 1279 by 256, and you'll get 4 point something, and you ignore the fractional part, and the 4 is your number. 4 goes here. Okay, and after you do that, you have to subtract 4 times 256 from 1279, and resulting number should be divided by 16 to figure out how many 16s are there. And that's 15 point something. So you write the 15 here, and then figure out what is left. And there is 15 left. So 15 times 16 to the 0 will make it complete. So the code is 4, 15, 15. But if I write it as 4, 15, 15, like this, I'm using the board now. Okay, if I write it as 4, 15, 15, like that, it would look like 41515. And someone reading it would interpret this 5 as 5 times 10 to the 0, 16 to the 0. And then this 1 as 1 times 16 to the power 1, which is wrong. It's actually 4, 15, 15, not 4, 1, 5, 1, 5. So when you have double-digit numbers like that, it'll be unclear for anyone reading it. So therefore, we had to use some different method. 1 second. So because of that, in hexadecimal coding system, the 0 through 9 will be used exactly the way we write them. But then 10, instead of 10, we use uppercase A. 11 will be written as B. 12 is C. 13 is D. 14 is E. 15 is F. So A, B, C, D, E, F will be used. So in hexadecimal coding system, the number will be written using numbers and letters, uppercase alphabets. So this 4, 15, 15 that we just figured out, the hexadecimal code of 1279 will be actually written as 4FF. So hexadecimal codes have alphabets in them. The shortcut method is also available for any coding system. Shortcut method is available. So let's see how that works. Oops, I don't have that written, but basically you divide the number by 16 repeatedly, just like the other ones, and write the remainder on the side. And maybe I can show you quickly. Clear the board. You can use calculator, you're not expected to do everything in your head. So 1279 you divide by 16. All right, so I'm going to use a calculator and tell you what the numbers are. 1279 divide 1279 divided by 16 is 79.9375. So I only write the 79 here. That's all I need. And to figure out the remainder, I multiply 79 by 16. So 79 times 16 is 1264. So I have 1264. So subtract 1264 from this, from 1279, and that gives me 15. So 15 is the remainder. Now divide by 16 again. So 79 divided by 16 is 4.93. So 4 will be written here. Now I had to figure out the remainder. To figure out the remainder, 16 times 4 is 64. Subtract 64 from 79, that's 15. So here's your code, 4, 15, 15, from bottom up, 4FF. As simple as that. You can use your calculator. One second, my code. Okay, let's move on. That finishes that section. And so the remaining even numbered problems in section 1.2 will be your homework. It doesn't include 16. You did the 16 in the last assignment. So it'll be 18, 20, 22 from 1.2. I'm going to proceed to the next lecture. So let's close this. Your assignment link will always show you exactly what problems are due in that assignment. Now, we have the course calendar all worked out, but it's very hard to follow that exactly. Sometimes there will be more problems than what is shown on the calendar, sometimes less, but you can always trust the assignment link. So let me close this and go to the Blackboard for a second and show you the submit assignments. So if you go to submit assignments, right here, for example, homework 2, you turned it in this morning or yesterday. It tells you exactly what problems are due here. So that's always correct. The course calendar can be sometimes off depending on what material we manage to finish. And also, some students have trouble uploading them. You click at this link to upload your work, and then you select your name. If it shows like this, select your name or type your name here, last name, first name, last name, and the submission title will be the homework number. Homework 3 will be the next one. And then click at this link to go to your computer storage device and find the file that you want to upload. And after you choose, so let me choose something here from the, all right, this is one of the students' assignment. I had to download it for a reason. And select just some name, I'm just making up a name. So if I say upload, the file name is right here. And if I upload it, then it'll try to upload and it'll bring up.
It's asking for a title.
Oh, okay. Yeah.
Under the last name, it says submission title. There you go.
Yeah. Okay. Thank you. Okay. And upload. And the file shows here. You can see that now, right? Right here. So if the file is not showing here, that means it's having trouble uploading it. And if you type your document, it'll have no problem uploading it. Only when you handwrite, depending on how good your handwriting is or whatever, I don't know exact reason, the handwritten documents sometimes have difficulties. You have to take picture of it, or even if you make it PDF file, it has trouble uploading it. So if it doesn't upload, it will attach it as a document to the system, to the assignment system. And attachment can be graded. I can download and grade it, but the only problem is I won't be able to write feedbacks. You won't be able to see any feedback that I can write. I cannot even write feedback on the downloaded document because it has to be within the Turnitin assignment system for me to be able to write the feedback. So your answers can be very short. They don't have to be very long. As you can see, this is the first assignment of one student. Uh, this was from one student, and I'll open it directly here so that you can see. I'm using it as an example of how brief you can be, all 12 questions. He actually wrote all the questions, the answers of all the questions in a half a page right there. That's all you need. So don't write too much, just answer the question. For the question, for example, the question that said, um, what are the components of the computer system? The correct answer is just this, input device, output device, central processing unit. That's all you need. But some students were explaining what input device is, output devices, and all that. Don't write all that, just answer the question. That's all we need. So if you just answer the question, then it'll be half a page. At least this one is half a page. So that's not too much to type. So if you type it, it'll be a lot easier. It'll upload properly, and also I can write feedback and everything. Um, so now, before I proceed, I don't believe you have questions from this homework. Anybody has any question on this homework? Here are the answers from one student. This is from one student, and that's very brief. And that's all you need to write. Okay. Anybody has any question on the homework? All right.
No,
I
that's
actually
fine.
do have a question.
Sure.
What's your grading policy for the homework? Like, how do you grade them?
Oh, how do I grade them? I first
Yes.
assign points to each problem, and usually I put that at the top. It usually shows. I can bring up one of the assignments, one of the graded assignments. I hope the students don't mind. So I'm going to go to,
Actually, do you mind pulling out my homework? I'm right now very concerned about what's happening with it. Cause you gave
You
me
don't mind others seeing it?
Yeah, I don't mind, but like I got 60 out of 100 on this. Like I'm very confused on what the hell's going on.
All right, I can bring it up. Okay, what is your name?
David, back.
David Back. Okay, right there.
No, the 1.2. This should be the second assignment he gave us.
Oh, I don't want to open that up because that's, oh wait, that has been submitted by everybody. Yeah. All right, I can open that up. See, I can see who have reviewed the assignment, the graded assignment. See these symbols that show me who have viewed it, who haven't. And David Back, you haven't reviewed your first assignment yet, right?
I actually reviewed it this morning. I'm not sure.
Okay, it's showing me that you haven't. Anyway,
All right.
you want me to go to the second assignment, the one turned in today. All right. Okay, David Back. Yeah, you got 60 there. See at the top, right there, I'm telling you what the grade scheme is. 4 points each for number 8 and 10, 2 points each for the others. Total is 20 points. You understand that, right?
Okay, it's because on my screen I did not see any of those comments.
I see. Okay.
Yeah.
Yeah, sometimes that happens. You just have to close it off and reload everything.
Same here. I checked last week, and I'm looking at your screen, and I'm
Yeah.
checking right now to see if I have it, but I don't have any feedback as well.
Uh,
Yeah, so I was trying to see if what did I do wrong. But I got 85, but I just wanted to see what I
okay.
did wrong.
So if you don't see the feedbacks, you can always write back to me. And for
Okay.
some reason, if I open it up again and then close, then it shows up. It happened before. If I just open it up and then close, then the student can see the feedback. So it just has to reload everything, basically. So if you have that same issue, then send me an email message. I'll reload it. Okay. So here I have, so that's why, David, that you couldn't see it, that you couldn't see my comments. That's why you were wondering what happened, right?
Okay, yeah.
See, now it shows exactly where you lost points. Number 4, you lost 2 points because you didn't provide the binary code. You're supposed to find the binary code. Okay, this is not binary code. Understand?
Okay. Yeah.
And same thing here, problem 6. You're supposed to find binary code and you have something else here. So let me open a correct answer. Let me open one of the correct answers, 100%. I hope these students don't mind. Tatiana Almonte.
Yeah, you can view mine too if you want Christopher's.
Which one?
Christopher?
Christopher Huang?
No, Legarda.
Lagardo with the L.
Yeah.
Okay.
All the way at the top.
All the way.
Yeah, yeah.
Okay, got you. Okay, so Christopher, you don't mind opening that, right?
No, go ahead.
All right. So he wrote by hand and it worked. You know, I mean, handwritten assignments don't always fail. They fail sometimes. This one is handwritten, but it worked. So I have marked right or wrong. And whenever it's wrong, I usually write an explanation. And here's the wrong answer. And I have the correct answer written. It's 1,440,000. And you have extra 3 zeros here.
Oh, okay.
All right.
Sorry.
So that's why it's wrong.
All right.
Other than that, you got everything right. So I indicate exactly what is wrong. And whenever it's wrong, I usually mention provide the correct answer. And then at the top, I tell you, you got 17 out of 20, which is 85%. So all the details are right there. Okay. So that's how the grading works. I tell you exactly the grading, the points assigned to each problem right at the top. And so using that, you can figure out what went wrong, where you lost the points and things like that. So Christopher has lost 3 points. Well, we don't have to figure that out. You can take a look at it yourself later. This assignment will be discussed next class because I haven't completed grading all of your work. Whoever submitted yesterday were graded, but others I haven't graded. All right. Any other question on the homework? Okay, moving on to 2.1. No, wait, I'm not finished with 1.3 yet. Okay, so let's proceed with 1.3. Okay, we have section 1.3 to finish. Let's go to that. Programming languages and compilers. So we have learned in the last section that machine language is the only language computer can understand. So everything must be written in machine language for the computer to be able to understand and execute. If it is programmed, the program must be also written in machine language. Everything has to be in machine language. The on and off setting is the only thing the machine can see. So everything has to be converted to that. So the program at the time the computers were first invented in 1950, the programs were written in machine language. They had to write it in machine language. They were, they didn't have any other idea. And machine language program is extremely difficult to work with because nowadays we don't even learn anything about machine language because things have been worked out differently. But in the early times of the computers, they had to write a program in machine language. So imagine everything written in machine language. Hold on, someone just came in.
Professor.
Yeah.
I'm sorry to interrupt, but I was just went to go look for my grade before, and I'm in the grade section and I don't see any grades. But I saw my name on that list earlier when you had everyone's name up.
Uh-huh.
I just don't see anything about my grades at all.
You went to the migrate page, right?
Yes, I did. That's what I'm looking at right now.
All right. You don't mind me going to your migrates?
I don't mind.
Okay. To me, it's a different place. For you, it's migrates. What's your name?
Anissa Montalvo.
With an M?
M. Yes. I think you just passed it. Oh wait, no, never mind. There it is. Yeah, down there. One down.
Not there yet. Montalvo.
You passed it.
It's right. It's right there, sir.
Oh. Montalvo, right. Yeah, right. The grade is right here. 100% for homework 1. And you didn't take the quiz 1. So there's no grade for that. And
I did take the quiz one though.
and you haven't submitted the assignment 2.
I submitted both already.
This morning,
No, I submitted it like 2 days ago.
2 days ago.
Yeah.
All right, then I can take a look at the assignments.
On my side, it says it's submitted, but I don't know what I can do.
Okay, I'm going to take a look at your assignment.
Professor, same thing for me. I just looked and checked for homework number 2 and it doesn't say anything. But I did submit it last night.
God, I'm not alone.
Yeah, I may not have graded yours yet, so that's possible, but I can check to see whether yours have been submitted or not. So I'm trying to see for Montalvo. You see your name anywhere here?
I do see mine. It says late, but I did submit it last night. This is Kelvin speaking, by the way.
Montalvo has not submitted. That's what
I
it says.
have it here with a timestamp that says it was done 2 days ago.
Mine also has a timestamp of last night, so.
The submission somehow didn't go through. So if it goes through, then it would say it's submitted. It would say something to that effect. And if it doesn't show that, then it didn't go through. All right. So Anissa, what you can do is send it to me my email. I will try to upload it and see what's going wrong.
Okay, thank you.
I can upload it for you.
Okay, by the way, Professor, mine does have a timestamp of 3:54 p.m. yesterday.
Yesterday. Okay.
Yeah.
What's your name?
Kelvin.
Kelvin Arias. Yeah. It says not submitted.
Okay, I will email it to you.
Yeah, email it to me.
So will I.
All right.
I have a question of how you want the assignments to be sent in.
Oh, they had to be submitted to the Turnitin assignment system, like I showed you a minute ago.
For my first homework, you said that dot pages is not good.
Oh yeah, that it didn't get submitted. So I just showed you a few minutes ago. If your submission goes through, it will even show you the page right there, and that's when it goes through. So yours was handwritten and it didn't go through. And when it doesn't go through the submission process, it attaches it as a document, and I will be able to download and see it. But the only problem is I won't be able to write any feedback on it. So if it doesn't go through, then you have to keep trying. And if it is completely failing to go through, then typing is the best way. If you type the answers, you only have to type brief answers. You don't have to type a whole thing. So let me show you one example of this assignment. This is assignment 2. So let me see. Someone with a full. Tatiana Almonte, I hope you don't mind. You have 100%, so there's no harm in showing that. I'm going to open that.
I don't mind, Professor.
All right, thank you. So here, look at this, very brief answers, right? That's all you need. And so this student drew the picture by hand for the circuits, but you can even write on, off in words. And the first circuit is on, so you could have written on, off, on, off. That would be fine. Some way to indicate that you understand the answer. So you briefly, it's all brief answers. All you have to write is the answer, and then so type it and upload it, it'll go through. If you type it and upload it, no matter what software you use to type, it'll go through. Only the handwritten ones fail sometimes. If they fail, they get attached as a document, and then I can grade it. Only problem is you won't see the feedback. Now, at this point of course, the feedbacks may not be important. The material is so easy, but later on the feedback will be important. When we get into serious programming, feedback will be important. You need to see that, see the feedback to learn from it and to do it correctly. So if it fails to upload, please type it. You don't have to type a whole lot, and typing the answers would be the best way. So, okay, so I hope you answered the question. I hope I answered the question. You had to upload it to this system, and if you upload it, it shows right there, and I can write my feedbacks. Like this one, you can see I can write exactly how many points I assigned, and what is wrong. Now, this student says 1,440,000 characters, and then she gives me the precise answer. I don't need that. I only need the approximate answer. So I write, my comments everywhere, and then you can understand. You can learn to do it properly by reading my feedback. That's how you learn. And so for the process to work, you had to upload it to the system properly. Okay, so any other question? So if you have trouble uploading, then email it to me. I mean, if it is typewritten, it should go through. And if it is handwritten and it's not going through, then emailing it to me is not going to help, because I'll have the same problem. So in that case, you'll have to type it. All right, so I'm going to close that one and go on to our topic, programming languages and compilers. So machine learning.
Professor, your is not showing you the slides.
What do you mean? You cannot see my screen?
I can't see your slides.
What
Yeah, I can see it now.
The back.
Okay. Yeah, by the way, you should use a computer. If you're using some other device, these displays may not display properly. Even iPad may not work properly, depending on what I'm displaying. So computer will be the best way. Desktop, laptop, any computer. All right, so no problem now, right?
It's good.
Okay. The early programmers had to write the programs in machine language. They didn't have any other way. So imagine a program written in machine language. It'll be bunches of zeros and ones, a whole bunch of them. Right now I'm writing a couple of lines only, but imagine having pages and pages of these things. And if you make a mistake, forget it. How do you find the mistake in this program? Programs are never right the first time. There is always a mistake, and then you have to go back and figure out what the mistake is and correct it and rerun it. And so it's a long process of very often. So if you have to write it in this language, it's almost impossible to figure out the mistake. So programmers were struggling to write programs in this language. And so the computer inventors, remember I mentioned to you that there were two professors at University of Pennsylvania who built the first machine. And they were having this problem writing program. And so they couldn't market this product because of that problem. If you can't write program, then there's no use of this computer. So therefore they had to come up with a better way. And so they came up with the way to do it. So what they decided to do was coming up with a programming language. Instead of using machine language for programming, they came up with programming language to write the program. And programming languages, so what they decided to do was design a programming language that'll be closer to English. That way it'll be easier for us to work with. And therefore it'll be, it will be convenient for humans to write the programs for. But if you design a language that's convenient for us, the machine is not going to understand that, right? So they came up with the method, and I'm going to explain that in a second. So the languages were, the very first language they came up with was called Fortran. Fortran was still used for a long time, up until year 2000 or so, it was still in use. And then, slowly it was abandoned. Then other languages evolved, BASIC, Pascal, COBOL, C. C was popular for a long time. And then C++ was a improved version of C, basically, that added object-oriented programming. Object-oriented programming is something you learn in your 272 class, and that was added to C to make it C++. So C++ language is now the most popular language. And then Java is also becoming popular, but it hasn't taken over the C++ yet. And there are other languages, Modular, Ada, and many more. So languages, there are many, many languages out there. When I was a student learning computer science, I had to learn several languages. Fortran, BASIC, Pascal, COBOL, I learned all of them. Because at that time, the computer science department required everybody to learn all the popular languages, because each one had its own advantage. Like COBOL was good for business programming, but Fortran was good for scientific programming. So each language had its own advantage and disadvantage. So everybody had to learn so many languages. But everybody, now after C language came along, pretty much the other languages went away, because C language was good for everything. And then C++ is an improvement of that. So that took over the market, and pretty much that's used by all the programmers. So anyway, even though so many languages are there, none of them can be understood by the system, right? So how exactly did they make this work? They made it work by coming up with the idea of compilers. A compiler is they were able to basically design the language, the programming language, and after designing the programming language, they had to come up with a program that can translate these programs, the program written in programming language, to machine language. It can be done by a program, because every word is going to correspond to one machine code, one machine language code. So everything you write, for example, if I write in C++ program to add two numbers, we use the symbol plus. We can use the symbol plus in the C language or C++ language. Then the plus will correspond to a certain code in computer machine language. So you can design a program that will translate the plus to that code. So for every symbol or every English word we use in the C or C++ language, there's a corresponding machine code. So the computer program can be written to write the machine code for each of the word we write in our C++ language. So that's what we call compiler. A compiler is a translator. It translates the program from machine language, from your language, for your programming language, whatever programming language you're using, to machine language. So the language, programming language, anybody can design. You have to just come up with the compiler that will translate it to the machine language. That's all you have to do. So that's why so many languages were out there for a while. So many languages were designed by different people, and they designed their compilers, and the program, the language became in use for a while, but they went away after a while. You know, the only language that lasted very long is the C++, and it is still the most popular language. So there is a compiler for C++ language, which will translate any program you write in C++ to machine language. So after you write the C++ program, you have to access the compiler to translate your program. After you translate the program, you'll have a new file which has the machine code version of the program. And that's the one you execute. So we will be doing all that most likely, yeah, next class. Next class definitely will be running a program in class, and I'll be showing you exactly how to run a program, the compiling and running and all that. So you need to be ready for that. Well, you don't have to, I mean, normally when I do it in classroom, I have the students do it with me in class, but that's not necessary. It's just going to be awkward. I won't be able to see what you're doing anyway, so it won't work. But you just watch me how I'm doing, and then you'll be able to do it. There'll be an assignment, a computer assignment right after that. And so if you miss the next class, you won't be able to do your assignments yourself. So please don't miss that class. Anyway, the compiler, for every language, there's a compiler. The compiler will be a program that can translate program written in that language to machine language. So you need to have a program, the compiler program, in order to use any language. Now, why not English? Why can't we write the program in English? We're using some words from English in these other languages, but we cannot write program in English. Why? Because English has, or actually all the natural languages have their own share of ambiguities. No word, a word has many meaning. It depends on how and where it's used. And we have too many words with the same meaning. And so all kinds of complications are there. For the compiler to be, for you to be able to design a compiler, each word you write must have one meaning, one machine code that corresponds to it. So that's why we are able to use some of the words in English language and the mathematical symbols we are able to use, but we cannot use all the words in English. That'll be too much, too difficult. So that's why English cannot be used. Words of English are used in this language. So more clearly, compiler is a translator. So a C++ compiler is a computer program which, when executed, it'll take a program written in C++ as input and writes the same program in machine language as output. So this output file will be automatically created by the compiler. And so when we say run my program, it'll run that output file. And you won't be able to take a look at that file after translating. The machine code will be in a separate file. It won't allow you to even open up and look at it because there's no point. There's no reason to. You won't understand it anyway. So it doesn't show you, but if you just say run my program, it'll run that machine code, not your original. The original program is called source code. The translated program is called machine code. So the only the translated program will be executed because computer can only follow that language. Okay, so executing a program. So when you want to write your program and execute, you first have to write the program on a paper. It's always recommended that you write it on a paper first. And when you're satisfied with your writing, you go ahead and type it using any editor. You can use any editor to type it, but you're going to need a compiler anyway. So all those compiler programs out there come with their own editors. So therefore, you can open up the compiler software and type the program using it, because they usually come with an editor. So type the program using it and then save it, then compile. Now remember, only the saved file can be compiled, not the one on the screen. The one you're looking at on the screen is only in the memory. If you remember, I explained what you're looking on the screen. Look, any document you're looking at, the display of on the screen is a display of what is in the memory. That is not on the hard disk. Only when you select the save command, this will be saved on the hard disk or external disk. So only the saved file can be translated by the compiler. So the file has to be saved on a device. So you can use a USB device or something to save it. Or if your compiler is on your hard disk, then this file will be saved on the hard disk. You don't have to use an external disk. After you type the program, you need to tell the system to compile it. And it'll take a few seconds to compile. It only takes a few seconds to compile. Compiling means translating. And during the translating process, it will find problems. If your program is not written correctly in C++. In other words, if some words you have written are not C++ words, it'll bring that up as problem. The compiler itself will be able to find them as a problem. So only these errors are called syntax errors, a violation of the language rule. That only that can be detected by the compiler. If your program is logically wrong, it's going to, it has a mathematical expression that's incorrect. Compiler cannot detect that. Program will produce wrong answer if your program is logically incorrect. So only the language errors can be detected by the compiler. So if there are language errors, it'll bring that up and it'll tell you what the problem is, and you have to, based on that information it tells you, you have to figure out where it is and correct it. And then after correcting, you save it again and then compile again. You have to keep doing it. Save and compile, save and compile. And then when it finally compiles, you can now say, run it. And then it will execute and produce the result on the screen. So that's how it goes. And I will be showing you how to do all that in class. Now, I have to show, I'm going to show it to you on a Windows computer. The computer I'm using right here is a Mac, and I have another Windows computer. And I will be showing you how to run the program on the Windows computer, because the software I'm going to show you is not available for Mac. There's only one compiler software available for Mac, but there are hundreds available for Windows. The one for Mac comes with the Mac, so you already have it. If you're a Mac user, you already have it. And I'll explain all that in the next class, but I'll be showing you how to work with a particular software in the Windows environment. And it is a free software, so you'll be able to download it. I'll give you instructions as to how to download it and all that. And so you can use your own computer and own compiler to do your computer projects. So after I teach you teach you how to run a program in the next class, there will be computer assignments periodically. All right, so moving on to programming environments. Computers are designed, there are many different types of computers. There are different size. They are grouped into 4 kinds, and so I'm going to explain what they are. Microcomputers are the smallest, the ones we use on the desktop. All the desktop computers and laptop computers are called microcomputers. They're the smallest kind. Microcomputers are basically to be used by individual. One computer can be only used by one individual at a time. But there are needs for other computers. So that's why we have mini computers and mainframe. The mini and mainframe are essentially similar, but slightly different size. The size is slightly different. So a mini computer would look like a small refrigerator. It's of that size, and it's very commonly used in mini and mainframe. Mainframe is just slightly bigger and more powerful than mini. Other than that, they are pretty much identical. They are usually about the size of refrigerator or a small refrigerator, and they will be sitting in one place, and they will be wired to many different terminals, and many people can use it at the same time. Now, let me explain why you need that kind of computers sometimes. The microcomputer is good for one person, and it has its own hard disk and everything built in. So, when you go to the bank, you have seen when you go to the bank and deposit money or withdraw money, there is a teller working with a screen and a keyboard, and opening up your account on the monitor and seeing the balance and then giving you the money. And if that person is using a microcomputer, then your balance information will be only saved inside that computer. And if you go to another teller, that teller wouldn't be able to access what the previous teller did. And so you can go and withdraw the money from the other teller, even though your balance is actually zero. So it will be right. All of the tellers must have access to your account, and any modification to the account should be immediately made to the entire file so that the other tellers can see it, right? So that's why you need a mini computer for bank. So in the banks, you don't see any computer. You're only looking at monitors and keyboards in front of those tellers. The computer itself is somewhere in another room, and that computer is connected to all these keyboards and screens that you're looking at in front of the tellers. And so the tellers are accessing the same computer using the keyboard on the monitor. The keyboard and the monitor combination is called a terminal. So each one of those tellers are using a terminal for their own use, but they're all connected to the one computer. Usually it's mini, sometimes mainframe, depending on the size of the bank. That's what the mini computer is. Multiple users are allowed, and they're all able to work with the same computer and work with the same files and manipulate them at the same time. The supercomputer is just larger. Not only larger, it has multiple processes. That's the main advantage with the supercomputers. Many processors are there, so it can do parallel processing, which means it can run many programs at the same time. So that's very rare, though. Supercomputers are not needed in normal businesses. They're used in some very few advanced businesses. One of them is our space program. Space program uses a supercomputer because they have to be very accurate with all their calculations with the path for the moon and whatever they were working on. So they use supercomputers. So very few supercomputers are used. Very common computers are mini and mainframe among businesses, and among other users like you and me, the microcomputers are most popular. All right, so that finishes section 1.3. And so that finishes chapter 1 altogether. And I'm going to go to section 2.1. And now, by the way, the homework includes all of 1.3. Like I said, I will be putting those exact numbers, the problems that are to be submitted as part of assignment 3. I'll be putting those numbers up in the link itself. Okay, so we are ready to go into computer programming now. We have the basic understandings of everything we need. After we discuss the computer programming, the basics of computer programming, we'll be able to write and run simple programs. And that's what we are going to do in the next class. Okay, so we need to understand what a variable is, and we'll be doing that in this section. And then we'll be learning how to write simple statements that instruct computer to store values in the memory, how to tell the system to store numbers in the memory, and how to tell the system to do arithmetic operations with those stored numbers, things like that. Very basic, very simple programs we'll be learning to write. Okay, so let's understand constants and variables and writing programs. So we need to understand the constants. Constants means basically the data, the numbers that we provide or characters we provide as data. They're called constants. You have to understand the details about these constants. And then we need to understand how we write instructions for the system to manipulate those numbers. And, you know, basically how to write all these simple instructions. We will be discussing all that in this section. So let's go to the constants, data. Numbers and characters, those are our data are usually numbers and characters. The data will be characters whenever we are doing things like word processing, then the data will be characters. So as we proceed to learn programming, we have to learn programming with numbers, to process numbers, also to process characters. You know, we also have to become programmers who can write word processors. So the constants are categorized into two, numerical constants and character constants. Numerical constants are numbers like 23 minus 7.5. These are all numerical constants. And character J, alphabet J, is a character constant. So whenever you're using a alphabet, any character as a character data within the program, you need to have single quotes like this around the J. The character should have just single quotes. And later you will understand why the single quotes will be necessary for the character data. So any character with a single quote around it can become character data in a program. Numbers will be directly written as numbers. 23 or minus 7.5 will be numeric constant. So let me explain numeric constant. So here we are dealing with a computer and everything has to be very precise. And we need to understand exactly what the computer considers a numerical constant, a correct numerical constant. And we need to make sure when we write the numbers, we write them that way. A numerical constant, right here it's highlighted, is a number that may contain a plus or minus sign, a decimal point, and that's it, nothing else. A number, a numerical constant, can have plus or minus sign in the front. They have to be in the front. And the decimal point can be there. So other than the numbers themselves, the only other characters allowed within a numerical constant will be the plus or minus at the beginning, a decimal point somewhere. That's it. No comma can be used. No other character can be used in a numerical constant. So like I said, we are writing these for a computer, so everything has to be precise, only then precise and exactly as expected. Otherwise, program will not work. So here are some, yeah, I said numeric constant and character constant. Two types of constants are there. The numerical constant can only have, other than numbers, it can only have a plus or minus at the front and a decimal point. Those are the only other characters allowed. Now going into the numerical constants, there are two types of numerical constants, floating point type and integer type. The integer type would be a whole number, a number that has, the integer number is whole number in math. In math, that's how we define it. But in computer science, integer number is defined as a number that has no decimal point. If it has a decimal point, it can be a whole number. If you have a decimal point at the end, then it is not integer number, it's a float number. So a floating point number will be a number with a decimal point. Integer number will be a number without decimal point. That's how it's defined in computer science. Okay, so 23.64 is a integer constant. I mean, it's a numerical constant, which is floating point number. Minus 5 point. If you put a point behind it, then it is floating point type. Only whole numbers without decimal point will be the integer numbers. So 34 is an integer, minus 4 is integer. Okay, that's how it's defined. So some of your homework problems have this kind of question. Are these valid constants? First, you had to identify valid constants, and then you had to be able to identify integer constants and floating point numbers. That's easy. Floating point numbers will have decimal point somewhere, integer number will not. Okay, so here's an example of such questions. 35.72, is this a valid data? And if it is, then what kind? It is a valid data and it is floating point number, floating point numerical constant. That is the answer. This is a valid data and it is a floating point numerical constant. This is also a floating point because it has a decimal point in the back. 284-5841, this is how we write phone number, and this is invalid numerical constant because of the dash. This is invalid numerical constant because of the comma. These you cannot write data for the computer with the comma in there. You cannot write a data with a, numerical data with a dash there. If you need to write things like this as data, they will be called string type data, and you will be learning them in 272 class, those who are going on to 272, and that's beyond the scope of this class. So we will be only dealing with numerical constant and character constants in this class, not strings. Okay, going on to character data, character type data. A character constant is any character in single quotes. Any character in single quotes can be used as a character data in a program. Single quotes are required when you're using them as character data. Now, after we learn a little bit more, I'll be able to explain why the quotes are necessary. When enclosed in quotes, even numbers will become, a number means a single digit number, can be also character constant, like these. Capital R with the quotes is character constant. Lowercase r is character constant. 7 with the single quotes is character constant. Any character, any symbol with the quotes around can be used as a character constant in a program. M is not a valid character constant because it doesn't have quotes around. 7 is a valid integer number, but not valid character constant. You had to put quotes around to make it character constant. Okay, so summary of the data types. There are 3 data types that we have learned so far. These are called data types. Floating point data type. A data is a floating point data if it has decimal point. If it is number, if it qualifies as a numeric data, and if it has decimal point, then it is floating point type. So these are the examples. The data will be integer if it is integer type. 34, -4, 7, these are integer type. The data is character type if it has quotes around, like the T, uppercase W, 4 with the quotes around. These are all character type data. So three types of data we have learned. We'll be learning more data types later on. So these are key pieces of information. There are three types of data, and the names are floating point, integer, and character. Okay, moving on. A variable would be a name that we make up to store a number in the computer system. The name we make up would become a name for the memory cell. So basically, you're making up a name to represent memory cell. That's how we access memory cells, by creating a name. So any name you make up and use in your program will automatically become a name for the next available memory cell. A memory cell, what I call memory cell, can be 1 byte long or 2 byte long or 4 bytes long, but whatever the memory allocated for that particular data is what we call memory cell. And that a memory cell may have more than 1 byte, depending on the data. So let's understand the variables a little more. You just make up any name to represent the next available memory cell, and then the memory cell can be accessed by that name. And you can store things in that memory, and you can retrieve things from that memory using that name, and you can refer to that memory, that variable, or that particular data by using that same name. So let me explain why this name is necessary. Imagine our memory, human memory. The computer memory is designed to work the same way human memory works. You know, computer is basically an attempt to make a replica of the human brain, but you know, it's not really a replica. It uses some functions of the human brain, not all of it. So this memory access method is done the same way we access our memory. So imagine if suppose I ask you to add two numbers in your head. So I put those numbers on the board on a paper like this. I say, all right, 23. One number is 23, and the other one is 7. I want you to add these numbers in your head. So imagine the process of going through that, going through the adding of these numbers in your head. You don't usually think about these steps, you know, the steps you're taking to do this, and now you have to think about that because that's what a computer program is. Writing exactly how we do things in our head. We have to write them to have the computer do the same thing using its memory. So it's essentially, you know, similar to what our brain does, you know, how our brain works, that we need to tell the computer to do the same thing by writing step-by-step instruction to do the things in the way our memory does, our brain does. So think about the steps you have to take. If I give you this piece of paper with the numbers written on it, and I ask you to add them and tell me the answer, add them in your head and tell me the answer, what is the first step you're doing? Think about that. You have the piece of paper in front of you with the numbers. Can somebody tell me what is the first thing you need to do?
Add a plus sign.
To add up the two numbers, the numbers are written on a piece of paper, and what are you doing first?
Assign a variable?
No, that's for computer. Now I'm talking about you, a human being.
Adding 3 to 7.
Say again?
Add 3 to 7.
I think you're. I'm having a hard time hearing you very well. Say it again.
3 to 7.
3 to 7. Yeah, no. That's not what I'm asking. if I give you two numbers on a piece of paper and ask you to add them in your head, the step-by-step your process you're going through is what I'm asking you to explain. The very first step is that you're reading the numbers. When you're reading the numbers, you're taking them into your brain, right? That's the first step. What's the next step?
Create a formula.
You're adding the numbers in your head. You're adding in your head 23 plus 7 is 30. You know,
If I'm adding 23 and 7 in my head, I'm
your
looking
head,
at 23 and 7
right.
and I'm just doing it.
And you come up with the 30. And where is that 30? The answer 30 now. That's in your brain now, in your memory, right?
Yes.
Yeah, you added them and you put that in another area in your memory. And what is the last step now? You have the answer in your head. What's the next step?
I have to say the answer.
You say the answer, exactly. These are the exact steps we had to write to make it all happen in the computer. We have to tell the system to store the two numbers in two memory cells. Okay, that's the first step. And then we have to tell the system, add the two memory cells together and then put the answer in another memory cell. That's the second step. All right, what are the steps? First step is store the two numbers in two memory cells. So next step is add the two memory cells and put the answer in another memory cell. The third step is tell me what is there in the third memory cell, right? Isn't that the process? That's exactly how the computer program would be to write these, to add these numbers in a computer, using a computer. Everything all the instructions we write will be telling the system to do something to the memory. That's what the memory is for the computer to do things. And so to tell the system to store the two numbers in the memory, the method is to make up two names for two memory cells. So you make up any name, you come up with any name, and then you use that name and say, put this 23 in that name, store the 23 in this name, store the 7 in this name. Then it'll be instruction to store them in the memory and give the memory cells those names. That's what those are. So that's what these names are for. You make up some names, and these names are called variable names. To make up these variable names, and you assign the data to those names. So here's an example. To tell the system to store 23 in the memory, I make up a name, num. The name can be anything. There are certain rules that we will understand later, but essentially any name will do. So I made up the name num, and then I say num equal to 23, and then put a semicolon behind it. You need to end every instruction you write with a semicolon. Every instruction must end with a semicolon. That's how the system will understand where the instruction ends. So this statement, num equal to 23, is a statement in the computer program. It's a C++ statement in the computer program that tells the following to the system. It tells the system to find the next memory cell for storing this number. And so you can imagine that being a box, a memory cell, and name that memory cell as num. So it's like a mailbox with a name on it. You have a name num for it. And also this instruction says store 23 in it. All that will be done by this program statement num equal to 23. So this is called a C++ assignment statement. Assignment means assigning a value to a memory or to a name. And it instructs the computer to select a memory cell, name it as num, and also store 23 in it. All that is set right there. And so if I want to say now, store the 7 in another memory cell, so I said in my previous statement, I said num equal to 23, semicolon. That did this work right there. And now I want to say store 7 in a memory cell. Can I write num equal to 7? If I write num equal to 7, then I'm saying erase the 23 in the memory cell now and put 7 in it. That's what I will be doing. I don't want to do that. I want to store 7 somewhere else. So what should I do?
Give it another variable name.
Another name, yes. So let's say I want to make up the name Val. Any name will do. You choose any name. And Val equal to 7. And that right there makes the computer choose the next memory cell and name it as Val and store 7 in it. All that is done by that statement. That's how it goes. So that's why the name, the variable name is used for. A variable name represents a memory cell. It's a name for the memory cell. And you can make up any name, it automatically becomes memory cell. So by creating more and more names, we can access all the memory cells. That's how you access. The programmer accesses memory cell by using a name. As simple as that. So the second, if I write a statement rate equal to 35, then I'm creating another memory cell where 35 will be stored. So here, another memory cell, and it's called rate, and 35 is stored there. All that is done by this statement. And if I say rate equal to val, let's understand what that will do. The rate has a 37 right now. But if I say rate equal to val, then that would mean copy the val into the memory cell rate. That's the meaning of that. It all
Professor,
goes in this
I
way.
believe we're over our time now. It's 9:17.
Yeah, it is time. Okay. So yeah, let me finish that statement I made. Rate equal to val means copy val, the value of this memory cell into this. So whatever this already has will be erased. And that's what that means. Okay, so we will stop here.